In this video, I will walk through some examples of simplifying complex numbers. This comes from homework problem 1.4.27, and specifically what we're asked to do is to divide, and then note this important final instruction that when we finish the problem, we want to put it in this form, the standard form for a complex number, a plus bi, where a is the real component and bi is the imaginary component. So let's divide this. What the problem is here is that the denominator has an I in it. Now, if you recall, I is the square root of -1. So in other words, the denominator has a square root. So to get rid of that square root, what we're going to do is multiply the 3 plus 6i times its conjugate. The conjugate is a number by which we could multiply and eliminate that imaginary unit. So for the 3 plus 6i, the conjugate is 3 minus 6i. So how do we go about dividing this? Or in other words, how do we go about simplifying this expression or getting rid of the radical in the denominator? We multiply the 3 plus 6i by its conjugate. Now we can't multiply the denominator by 3 minus 6i without changing the value of the expression. So what we're then going to do is multiply the numerator by the same value, the same expression, and now really all that we're doing is multiplying by a giant 1, 3 minus 6i over 3 minus 6i. So when we multiply by 1, we don't change the value of the expression. Let's see how that works out. And you might make note of the pattern. When we multiply conjugates, make note of the pattern that we get. So for the numerator, it's just FOIL. It's the first times first, outside times outside, inside times inside, last times last. So for the numerator, we're going to have, let me get the fraction line here. For the numerator, we're going to have 2 times 3, 2 times -6i, 3 times 8i, and then last times last minus 48i squared. I could simplify that, which I'll do in the next step here. Could simplify that to be 6 plus 12i. So do you see that I can combine the negative 12i and the plus 24i? So it's 24i minus 12i. So when I combine those, I'd have a 6 and then plus 12i. Notice that negative 48i squared, if you recall, if I is the square root of -1, then I squared is going to be the square root of -1 squared, or in other words, -1. So this negative 48i squared is the same as negative 48 times -1, or the opposite. It's always this I squared means you change that negative 48 to its opposite. The opposite of negative 48. So plus 48, and we'll be able to combine the 48 to the 6. Let's come back to that in just a minute. When we FOIL the denominator, because we have 2 conjugates, something really interesting happens to those i's. This sounds very gruesome, so bear with me for just a minute. But when we multiply by a conjugate, what we're able to do is pull out the i's. How do you pull out the i's? How do you get the I out of the denominator? You pull out the i's by multiplying by a conjugate. Now, if you think that you've multiplied by the conjugate, but you don't succeed at pulling out the i's, then you've done something wrong. So let's try that. 3 times 3 is 9. 3 times -6i is -18i. 3 times positive 6i is plus 18i. And then last times last, -36i squared. So do you see what I mean by pulling out the i's? This negative 18i plus 18i, those cancel each other out. So we're left with 9 minus 36i squared, which is the opposite of negative 36, so just positive 36. So how did I do that? Negative 36 times negative 1. So the opposite of negative 36, or positive 36. Well, that's just about it. Now I'll just rewrite this. 48 plus 6 gives us 54. 54 plus 12i. And then the denominator, 36 plus 9, gives us 45. And the final step is to write this in standard form, a plus bi. So I could rewrite this 54 over 45 plus 12 over 45i. And there is some reducing I can do, because 54 over 45, they can both be divided by 9. 54 divided by 9 is 6. 45 divided by 9 is 5. So I get 6 over 5. And now with the 12 and 45, they can both be divided by 3. 3 goes into 12 4 times. 3 goes into 45 15 times. So the final answer would give us 6 over 5 plus 4/15 I. And there it is. That's how you can divide complex numbers, or in other words, simplify the difference of two complex numbers. Hope that this tutorial has helped, and if you have further questions, please don't hesitate to reach out to me.